All right. Hi guys, here is your video, sort of the introduction to polynomials. So through the series of videos, we'll talk about polynomials, we'll talk about what they are, what they aren't. We'll go through some quick operations of polynomials, which should be a lot of review. And then we'll get into some characteristics of their graphs, talking about end behavior, the zeros of the graph. So we'll stick with this week talking about things that are in factored form, and we'll sketch polynomials that are in factored form. And then moving forward, we'll do some work with our graphing calculator. So that's just sort of a small plug. If you haven't gotten your graphing calculator, you should have one by this point in your mathematical careers. But if you haven't gotten one, this would be a great time to get one because we will need it for next week. So here's just some quick vocab that we'll go through. So there's a lot of vocabulary here, so if I'm going too fast, remember that you can pause and rewind and sort of revisit some of these words. So polynomial, it's a mathematical expression that's made up of terms. And so specifically, the terms can have exponents, and the exponents have to be whole positive numbers in order for this to be considered a polynomial. So we're talking about natural number exponents here. So again, just a little reminder, there's a lot of vocabulary here, so you can pause, you can rewind, so just make sure that we're sort of taking all these terms in. So this is a mathematical expression, 4x squared plus 3x minus 7. There are two major ways that polynomials are described. So looking at this polynomial, first by the number of terms that it has. So terms are separated by addition and subtraction signs. So this polynomial has 3 terms here. We have a leading term, and with my leading term, I have a lead coefficient. So here I have a lead coefficient. I have a constant term. So the constant is the term that is not paired with a variable. And here I would call this the linear term since it's paired with the x to the first power. So again, we have the leading term, the lead coefficient, and the constant term. So the lead coefficient here is 4. And once more, terms are pieces that are separated by addition and subtraction in the polynomial. The leading term, so sort of another way to describe the leading term, is the term with the largest degree. And when we talk about the degree of the polynomial, we're talking about the largest exponent. So I can see here, this has an exponent of 1, that x value. This is really like x to the 0 power. So whatever the largest exponent is in your polynomial, that is the degree of that polynomial. So constant term, which we already chatted a little bit about, it's the term that has no variable or a standalone number. So no matter what I plug in for x here, this term will always be -7. It will always be constant. So we talked about how they are sort of categorized by their number of terms. So polynomials that have 3 terms are called trinomials because they have 3 terms. Polynomials that have 2 terms are called binomials because they have 2 terms. And polynomials that have 1 term are called monomials. So anything larger than 3 terms, we just call a polynomial. So the second way that polynomials are categorized, aside from the number of terms, is looking at the individual terms specifically. So we have these coefficients here, so looking and analyzing at the individual terms. So I have these 2 coefficients, and remember that 4 is my lead coefficient here, -7 being my constant. Again, we have the leading coefficient. And so the coefficient is the number that's paired with the variable in the term. The lead coefficient is the number that's paired with the variable in the polynomial that has the largest degree. So again, 4 is my lead coefficient because it's paired with the x squared here, and 2 is the degree of the polynomial. So degree, the largest exponent here. So those are just some polynomial vocabulary terms. You may have heard of some of them before, you may not have heard of some of them. So here, just so that we're all in the same field when we describe these polynomials, these are terms that we'll need to use sort of fluently moving forward.